Monitoring the status of an uplink from an HSRP router is extremely important. Now, why is that? Well, let me paint a picture for you here. We'll just draw in some devices. We have our client and our distribution layer switches, which are the default gateway, as well as the access layer switch. The cloud is the core, something out there. Could be anywhere. Just representing everything else for us. Currently, this router is active. This router is standby. What if this link fails? The standby takes over. It's pretty simple. What if this device fails? The standby takes over. What if this link fails? Or connectivity to the core further along, or to particular devices fails further along the path? Then this device remains active. Standby doesn't take over because the active router still is sending hello packets back and forth to the standby. And as a result, the standby says, oh, active still exists, still has a higher priority. And active's telling it, hey, I exist. Even though it can't reach any resources. So what's happening to the traffic? The traffic from the client is still coming from the client, going to the active, and then getting dropped. It's getting dropped because the active router can't forward it anymore because this link is down, or some other link further along the path is down as well. So how can we track the status of upstream links or upstream devices? We can use interface tracking or object tracking. So interface tracking is a built-in feature for HSRP, and you can simply track the status of an interface locally. But you can also use object tracking to monitor the status of a particular interface. So either or works. And what happens is that you are monitoring to see if that interface is up or down. If it's up, don't do anything. If it's down, decrement the local priority. So if this router has a priority of 110 and this router has a priority of 100, the goal is to decrement the priority to a value that is less than the value of the standby router. So if that is 100 and this is 110, as long as we lower it to 11, or pardon me, as long as we lower it by 11 or more, so it becomes 99 or lower, then we've accomplished our goal if this particular interface goes down. Standby becomes active. That is the goal. Now, what if, for some reason, traffic based on monitoring the flow in our organization continuously is going this way? It's going this way. Now, that's not the standby router, then. That is the active router. So why is that the active router when this is the standby router? Well, it's very likely that this link is down. Let's examine that here. I've created the same type of scenario for us. If we go to our client and we issue a trace to 192.0.2.1, we'll see that the trace is going to fail. Pardon me. No, the trace is going to go through DSW2. It's not going to fail. Why? Because DSW2 is currently the active forwarder. That's what's going to happen. It's going to take a little while here. For some reason, it's pretty slow. All right, we'll see here. 10.1.1.2 is our hub. It's not supposed to be, though. We want it to be 10.1.1.1. So there's something wrong right now in our environment. Right now, DSW2 is currently the active forwarder, and we don't want that. So let's jump over to DSW2 and type in show standby. And we'll see from this output that it is active for group 10. There's the virtual IP address. There's the virtual MAC. We can see that the active router is local. Our standby router is 10.1.1.1. So DSW1 is the standby router. This means right here that DSW2 can actually see DSW1. It knows it exists. And look at its priority. Its priority is currently 90. That's right. DSW1's priority is currently 90. Whereas DSW2's priority is 100. So it makes sense why DSW2 is the active forwarder. It's because DSW1 has too low of a priority. So we jump over to DSW1, we type in show standby, and we conclude that the priority is 90, but be careful here, the configured value is 110. So you might jump the gun and say, hey, whoa, yeah, we just realized on DSW2 that priority is 100, and DSW1's 90. Oh, we configured the priority wrong in DSW1. Let's go fix that. You get to DSW1, you're like, yep, priority's 90. No, it's actually 110. It's 110, but it's been decremented to 90. That's what that means. So what has caused it to be decremented? It's this tracking object right here. So you have to be careful with that. Don't just jump in and say, oh, yeah, we made a mistake with the priority configuration. No, we didn't. It's the fact that we have this tracking object configured that we have our value decremented. So we've concluded here that we are looking at object tracking as the issue. So if we type in here, show track, and we want to look at tracking object number 1, we can see from this output that we're tracking an interface, and that interface is Gigabit Ethernet 1010. And we're tracking the status of that interface. Is it up or is it down? And we can see here that it is down. And it's down because somebody typed in the shutdown command. It's administratively down. Oops, we shut off the interface when we shouldn't have. If we analyze the output of show run, interface VLAN 10, we can see the configuration for that tracking object is right there. Standby 10, track 1, and we're going to decrement 20. So this is the command here that links us back to that particular tracking object that we had configured to monitor interface Gigabit Ethernet 1/0/10's line protocol status. So we need to re-enable that interface. But let's just double check that. Show interface, show IP interface brief, and we want to look at Gigabit Ethernet 1/0/10. And it is administratively down. So configure terminal, interface, Gigabit 1/0/10. We'll say no shut. We'll let that do its job in the background. We should see it come up. We'll see that the HSRP group comes up. We'll see that an EIGRP neighborship is formed. So I'm feeling pretty confident now that everything is working. And just by the fact that it says right here, we're active, confirms that everything's good for us. But I wanted you to see the tracking object also went from down to up. So based on the fact that the tracking object came up, we then increased our priority from 90 back up to 110, and we became the active router. So if we look at the output of show standby, we'll see that here as well, that the priority is 110 now, and configured is 110. We'll go back to PC1. Let's do a trace. We'll see that the trace on PC1 successfully goes through 10.1.1.1 now, which is DSW1, because it is the active forwarder.